10 and start to talk about the very first kinds of polynomials you'll learn. Then we'll go to grade 11. Then we'll go on to the new stuff. So let's go all the way back to grade 10 in your head, unit 6. It's been a while. What was the very first polynomial you learned to graph? Here's a hint. The degree is 1. What do we call it? It's got a name. What kind of functions were those? Linear. Positive leading coefficient, what that means is what did it look like when m was positive? And what did it look like with a negative leading coefficient? What did the line look like when m was negative? So what does a line look like if it's got a positive slope? It goes positive, lots of people flinging their arms. Yes, give me a better mathematical description. To the right, x values are positive. Are they all positive? Okay, it's a little bit better math description. What to the right? Words, not their strong points. Rises to the right, right? Because remember, slope is rise over run. Okay, so we know generally that it looks like this. And what we're going to talk about with polynomials is what's called the end behavior. And so what that means is on the left, the line is going down. The end behavior is physically pointing down. But on the right-hand side, the end behavior is up. Okay, so it's physically which way the arrows are pointing. On the left, it's pointing down. On the right, it's pointing up. Well, what about if we have a negative leading coefficient? Again, fancy way of saying m is negative. What does the line do? But depends which way you're measuring the angle. It's kind of. Can we work on that a little bit? So what does it look like? Everybody draw it in the air. Draw it. Okay. Describe it. Well, we know negative slope because we started with that. Describe what if I don't know what slope is? Linear can mean a lot of things. Rises to the left, it goes down on the right. Okay, again, we're going to talk about the end behavior with all these graphs. So that means on the left, it is going up. And on the right, it is pointing down. So we spent all grade 10 just talking about lines. Then we came to grade 11. We're like, yeah, degree of 2. And we spent 4 units on polynomials with degree of 2. What did we call them? Parabolas was kind of its nickname. Quadratics. Positive leading coefficient, what that means is that the direction is up. So if it's the first number is positive, we know it's a parabola pointing up. And if the very first term is negative, we know it's pointing down. Okay, let's look at the end behavior. On the left, is it pointing up or pointing down? Pointing up. And the end behavior on the right? Up. Ooh, compare. Look what's happening here. Look at the end behavior for the line. Look at the end behavior for a parabola. What do we know about the end behavior when it's pointing down? Down and down. Then when we did transformation, so unit 3 for us, we started to talk about this guy a little bit. We drew the base graph. We did some transformations with him. What did we call him? Cubic. Why cubic? Because it's x cubed. Okay. So when the leading coefficient is positive, we end up getting that kind of snaky feel to it. Okay, so kind of like our base graph. If I were to throw a negative in front, well, we now know what's a negative in front of something in terms of transformations. Vertical reflection, and what's going to happen to this if I reflect it vertically? So it starts by pointing down and ends with pointing up. If I flip it over, it's going to start by pointing up and then go pointing down. And that's just because of transformations. Okay, let's look at the end behavior. So when it's positive, the left is going down, and the right is pointing up. Well, interesting, look at that. But this one's different. Okay, let's see if the same pattern's going to hold. On the left, it is pointing up, and on the right, it is pointing down. Take a look here. So why are these two the same and this one's completely different? Well, let's do some more. I just want to go back up to a definition. So the graph of a polynomial, it's smooth and continuous, so it doesn't have any holes, it never has asymptotes, and it mostly has what we call hills or valleys. And that's going to become a little more evident when we do the next couple. Okay, so never has holes, never had asymptotes, it's called smooth and continuous. Okay, you haven't officially seen these guys before. Exponent of 4 is called a quartic. Okay, just like there's 4 quarters in a dollar, 4 quadrants to the grid. He starts at the top, has a min, has a max, has a min. So our parabola is our u, our absolute value is our v. What's our quartic? It's the w. If I were to throw a negative in front, that's just a vertical reflection. So what is this going to look like? So down and a max, and a min, and a max, and down. It is an M. You are children of marketing. Okay, let's look at the end behavior. So if it's positive, it is going up and up. If it's negative, down and down. Okay, so I'll flip, you stay on this page because we need to see both together. Okay, so let's take a look at the patterns, what's happening here. So which other one went up, up, down, down? The quadratic. Okay, so what's the relation between the quadratic and the quartic? And it seems like the relationship is between the linear and the cubic. Odd and even. Okay, so let's go to our degree of 5. What do we call it? Quintic. God forbid someone have 5 babies. They're called quints. Okay, what do you think it's going to look like? So which way is it going to start on the left? Which way is it going to point? Okay, we think it's going to go down on the left and up on the right. Now another thing that we talked about a little bit, this we know from grade 11 has 1 max or min. We know that because we solved for it. We did word problems with these guys. So this has 1 max and 1 min. So this has 1 max or min. This has 2 max or mins. What does a line have? 0. So 0 max mins, 1 max min, 2 max mins. Take a look at our quartic. 3 max mins. What do you think is going to happen here? So this starts from the bottom. Max, min, and up. There's a quintic. If I were to throw a negative, just a vertical reflection, so it's going to go the other way, come from the top, min, max, and down. End behavior on the positive leading coefficient. Left goes down, right goes up. Does that follow our pattern? So flip back and look at, we said the linear and the cubic should be the same. Does it follow our pattern? Okay, what about our negative leading coefficient? Up and then down. Check if that follows our pattern. So we could keep going. We could do a 6th degree and a 7th degree and an 8th degree. We just don't because they don't have special names. But tell me what you think a 6th degree polynomial is going to look like. 5 max mins. Up and up. If it's got a positive leading coefficient. What if it's got a negative leading coefficient? Starts down and has 5 max mins and ends down. Okay? So just a little bit of theory. The end behavior of an odd polynomial graph, and then we'll talk about the end behavior of an even polynomial graph, and then we'll talk about the number of max mins. So just summarizing what we just found into words for the wordy people. It's an odd degree polynomial graph, and it has a positive leading coefficient. The left-hand side goes. So here's an example of an odd degree polynomial with an even leading coefficient. Left-hand side goes down, while the right-hand side goes up. And for a negative leading coefficient, the reverse is true. What about for our even polynomial? Okay, so just look up at the quartic. Left-hand side goes up. Right-hand side goes up. And for the negative leading coefficient, the reverse is true. The number of max mins for a polynomial of degree n is? N minus 1. So degree of 1 has 0 or none. Degree of 2 has 1. Degree of 5 has? Degree of 10 would have? Ooh, imagine how much fun those are going to be. Grab paper if you don't have yet. First example, you're going to turn and talk. So for each of those functions, you're going to tell me if it's polynomial, yes or no. If the answer is yes, you're going to give me the degree, the name, describe the end behavior, and tell me how many max mins. So you don't need to draw a picture, just talk to someone. Okay, letter A, polynomial, yes or no? Ooh, I heard both, yes and no. Fight it out. It's got only one variable. How do you tell if something's a polynomial? Well, if you actually looked on the other sheet, I gave you the definition at the top. What's the definition of a polynomial? Actually, the actual formal definition is higher than that. And the key is that the exponents have to be, is it right there? Whole number. Highlight that or underline it or circle that if you missed it. That's the key. Exponents have to be whole numbers. Okay? No negatives, no fractions. Exponents have to be whole numbers. If they are fractions, what kind of graph is that? Kind of. Not so much. It's like the square root graph. Those are radical graphs, is what we did last unit. What if they are negatives? Those are rationals. It's what we did last unit. So we've already done where the exponents are fractions, radicals. Negatives are rational. So we've done. They have to be whole numbers. So let's go back to A. Is that a polynomial? Yes, because the only exponent is 1, and 1's a whole number. What do we call it? Linear, degree of 1, end behavior. But the end behaviors would tell me the left and the right. So the left, it goes down, the right goes up. So we call that down, up is the end behavior. Down, up. Number of max mins? None, nada. B, polynomial. No, why not? Yeah, that's hidden, but you know from grade 10 that radicals are an exponent of a half, so that's when it's done. What about C? So check the exponent. Yes, degree of 2, name, quadratic, end behavior. So down, down, we call it, left goes down, right goes down. And number of max mins? 1. D was the tricky one. Let's see who got caught. Is it polynomial? Yes. What's the degree? 5. And just be careful with these is because your eye's going to go to the first term, and your eye's going to see x to the 4 and call it quartic. You just need to glance all the way through because it's 4 the highest exponent. No, 5 is the highest exponent. So even though we like them to be in order, sometimes they'll give you them like this. Okay, so make sure you're checking. So yes, it's polynomial. It's a quintic, degree of 5. End behavior. So you just need to look in front of the x to the 5, up, down. And number of max mins? 4 of them. That's the theory, what we need to know to actually graph. So I don't want to go on until we are good with that. Questions, comments? Okay, purpose of doing all that is to be able to graph these quartics and quintics and cubics. You're going to need your sticky notes, so if you haven't dug those out yet. Did you want another pad?
That'd be nice.
Yeah. Just put your IOU on the board.
Oh, do you want me to put your name up?
Anyone else need another one? Remember to put your name on the back, so if I find them, I can make fun of you. So steps we're going to follow. Step 1, we're going to name it. What's the point of naming it? Because then we can think about the end behavior. So before we know anything else, we'll know what the left-hand side and right-hand side is doing. That's going to help us picture the graph. So before we can even get values, we're going to know what the end behavior is and how many max mins there are. Then we're going to find the intercepts, because those are always great points for graphing. And then we're going to use table of values, which really is just a test point to figure out what's going on between. Okay, so step number 1, name it. Now this is not something you would normally have to write down. I'm just going to do this one step by step so you can just follow the first example later. So we're going to name it, look for the highest degree. Highest degree is, so that means it is a cubic. Point of naming it is so we can start to think about the end behavior. So this is a cubic, and the leading coefficient is negative. Tell me what you know about a cubic, and the leading coefficient being negative. Up, down is the offer. How many max mins is a cubic going to have? So we know it's starting from the top. It's got to have a min or a max, and then it has to go down. Okay? We don't know how high the min and maxers are. We don't know where they are at this point. We just know there has to be 1 min, 1 max. So that's the purpose of what we did this morning, is just to kind of get the general shape before we actually do some calculations. Step number 4 is to get the intercepts. Which one would you like to do first, x-intercept or y-intercept? How do we calculate an x-intercept? Okie dokie. How do we solve that? How? Well, if this was just a quadratic, how many ways are there to solve a quadratic? 5. But it's a cubic. How many ways are there to solve a cubic? 2. Graphing, which is always a way to solve any equation, and factoring, which is what we did yesterday. So this is always going to be a factor, and then split and solve. Factor, split, and solve. That's why we did the factoring yesterday, and we did the factoring, or the stuff the day before in order to do the factoring. All comes down to this. It's just to be able to draw the graphs. Okay, how do we factor a cubic? It's like we didn't even talk yesterday. Guess and check a number that equals 0. Then do synthetic division, take the answer from synthetic, factor it, and then put it all together. Okay, guess and check a number. This is where you give me a number and we check it. Negative 1 cubed. Negative 5 times 1 squared. Negative 6 times 1. What do we already know? It's not going to not equal 0. Not going to not. It's not going to equal 0. So what does that tell us about 1? Not a factor. Okay, give me another one. Okay, lots of negatives in this first term, so let's just do it by bed mass. So first we'll do the negative 1 cubed. So negative 1 times negative 1 times negative 1. Negative 1, and then times this negative, it's going to be positive 1, because there's 4 negatives in total. Negative 1 squared times negative 5. Negative 6 times negative 1. What does that tell us? No. Now, if we'd used a bit of logic, we should have known probably 2 wasn't a good choice, because when we did 1, all the terms were negative. So was that ever going to equal 0? So it probably should have told us 2 would also all be negative, but nonetheless, we tried it. What would you like as our fourth option? Yay! Why are we happy that this is 0? What does that tell us about negative 2? And the factor would be? Whew. Okay, now what? Okay. On the outside. On the inside. What do we check for in this step? All in order, anything in between missing, any holes? Okay. And what did we talk yesterday about this 0 here? Or? Okay. Okay, how do we factor this guy? So 2 terms, they both have an x, we call that. What kind of factoring? When it's common to both terms, we call it common factoring. Okay, what's common between the 2? Offer of x plus 3. Okay, so piece it all together. We know the polynomial is x plus 2 times x plus 3. And the negative x I'm going to throw in the front, because typically we wouldn't put it at the back. So if the question had said factor, that's where we would have stopped. but we're actually trying to solve this. So now we're just going to split it and solve it into the pieces. And that's what he was doing in the video. That's why he was changing the signs. So we know that minus x equals 0, x equals negative 2, or x equals negative 3. What do I do with minus x equals 0? Yeah, x still equals 0. Okay, so factoring, you'd stop here. This is solving. So the points are 0, 0, and negative 2, 0, and negative 3, 0. So go back and look up at the first thing we had up here. Would there have been an easier way to start this one? Okay, but if we didn't know that, is there an even easier way to factor this way up here? We could have done common factor up here, which would have saved us all this work. Okay, so you might want to make a note, check for common factor first, because it's going to make the question easier for you. Okay, we could have just factored out an x, and we would have been left with negative x squared, negative 5x minus 6, and then we could have just factored that. Whew, but we're not even done yet, because we have to do y-intercept. Ooh, yeah. Down here. But again, we made it 10 extra steps, but that's okay. Okay, y-intercept. Oh, how do you already know it's 0? Right, we talked about this before. If you get 0, 0 here, then we know that's 0, 0. Okay, so grab a sticky. We're going to start by plotting the intercept. So 0, 0, negative 2, 0, negative 3, 0. I'm grabbing a pencil on purpose, so if you don't have a pencil, don't do this step. But I know it's got to go up here. How do I know that? Because we already decided that in step 2, that the left-hand side has to go up. What do I know about the right-hand side? It has to go down, so I know that it's down in that direction. What do I know about in between negative 3 and negative 2? So this is step 3 where we pictured the shape. What do I know in between negative 3 and negative 2? It has to be the min. I don't know exactly where it is yet. I don't know if it's little. I don't know if it's further down, but I know the min has to be there. What do I know about between negative 2 and 0? There has to be the max in there. I don't know the height of it yet, don't know how big it is, but I know this is what the shape of the graph has to look like. Because we decided that in step number 3. So we know the end behavior is up, down, and we know there's a min before a max. And it always has to be in between the x-intercepts, just like a parabola. So the only thing I need to know exactly is what's going on at the min and what's going on in the max. So I'm going to use some test points. What is a good point between 0 and negative 2? Negative 1. So I'm going to step 5. I think I circled the other one, so I need to circle that one. And let's test at negative 1 and see what's happening. Well, be smart. We actually didn't do all this work for nothing. We've already tested minus 1. Okay, so where did we test minus 1 and how can we use that? Right here. And if we had actually simplified it, I hear like little mumbles of 2. Okay, so we know this is equal to 2. So that gives us the point minus 1, 2. And if you just want to make a note for later, this is just from step 4. So now I know that it's minus 1 and 2. What would be another good point to test? Well, right now, what do I know? What's going on? What do I not know? Well, I don't know where this min is. So what am I going to test to figure out where the min is? Negative. I know negative 2. I know negative 3 has to be negative 2.5 because it has to be right in between. This would be a calc question. So they're not going to make you manually test a fraction like that. So grab your calc. Okay, sub it into the original question, see what the value is. I don't know the answer because I haven't done it, but I know the answer has to be negative. How do I know that without even looking at it? How do I know the coordinate has to have a negative y value? Because it's a min, right? So just from the shape of the graph, I don't know specifically the value, but I know it has to be negative. Who's got an offer? No one has an offer. Lots of you punching away, but nobody offering. Can I round to 0.6? Can I get confirmation on negative 0.6? Okay, so what coordinate is that giving us? Okay, so halfway in between, middle of the box. And from there I can just join it. I know it's coming down, going through the intercepts through the min, coming up through the max, and pointing down. And there's our first cubic. These typically we don't do in red because there is no other graph. It wouldn't be wrong if you did. How do we feel so far? Meh. It's a lot of steps. Okay, more we do, the easier they're going to become. So let's look at number 3. Step number 1, 2, and 3 we do together. So we're going to name it. We're going to think about the end behavior, picture the graph, and how many max mins. So what are we dealing with here? It is definitely a cubic. What's the end behavior of a cubic with what kind of leading coefficient? Positive coefficient, so picture a cubic, positive coefficient, down and then up, confirm. Okay, how many max mins? 2, so I know it's going to go down, min or max min, and then go back up. None of that you have to write down. If you're visual, you might want to, but if you can just see it in your head, that's great. So none of that is required. It's just to help us get the picture of what this is going to look like in the end. X-intercepts. What number would you like to try? Equals? Yeah, we're always so happy when we get our 0 on the first try. Well, let's back up. And one of the homework questions was asking you about this, and it really goes with the video we watched. Take a look at the last number. It's a 2. So our only possibilities for numbers are 1 and 2. We could never have, for example, a root of 3. Not a root of 3, a x-intercept of 3. Why would we never get 3? Well, because we can't multiply anything to get 2. We would never have 4 or 5 or anything higher than 1 and 2. So use the last number to help you figure out what your test point's going to be. Okay, what does that mean if we get an answer of 0? The one here? So the factor is x minus 1, but then to solve x is what we put on the outside. Do you see it? Okay, what does this leave us with? Again, if the question just said factor, that's where we would stop. We need to actually solve it. What about this guy way up here? That's why I like to write in this step is write the factor, because it's easy to forget about him. And so that's why I like to put it in red and put it really loud and big so that you don't forget when you come down to here. And so our third x-intercept is 1. Y-intercept, where do I want to put you? Oh, I'm going to squeeze you down here. How do we find a y-intercept? Okay, so put in a 0 for every kind of x. What's the only thing that's left? Okay, grabbing the sticky. So applying the x-intercepts, we have 1, -2, -1, and 0, -2. Just going from what we have here, the little shape, again, I like to do this in pencil. We know it's going to come from down. There's going to be some kind of max there, and then it's going to loop through those 3 points and go up. Let's pretend I actually hit the y-intercept there. And that just comes right from the step here, what we saw over here. What's the only thing we don't know? It's just the max. We know where the min is because it's told us it's the y-intercept because that's right in between these 2 points. The only thing we don't know is the height of the max. So how do we find the height of the max? Test point. Okay, so what's between these 2 intercepts? Confirmation? Yes? Yeah, 0.6 positive. Crap. Typically, the closer together the x-intercepts are, the smaller the max and mins are. I tried to white that out, but that's not working. Okay, so if they're really close together, you're not going to get a huge high bump. It's going to be a pretty low value. And so just completing what we know, it's got to loop through that max and the min, and the end behavior has to be down and up. How could we check this? Because sometimes in the book there's no answers for graphing questions. Put it into your calc. So graph the original and look at it. So for my right brains, just going to put what we talked about into a table. I'm going to tell you how it works in my head. If it doesn't work that way in your head, that's fine. So we obviously need to split into even and odd because we've looked at the patterns of those. And we need to do positive leading coefficient, negative leading coefficient. And I don't memorize all of them. I go with the ones I know the best. For the odd, the one that you've drawn the most often is a line. So I think of a positive line, and I think of a negative line. So even if it's a cubic, even if it's a quintic, I picture a line because they all have odd polynomials. And a line you've drawn a million times. And so I know it goes down and then it goes up. And the negative is going to be the other way, which is up on the left and down on the right. So I don't memorize cubic and quartic. I just think of a line because they all have odd polynomials and you're used to drawing lines. What's the most common even degree polynomial that you've drawn a bazillion times? Parabola. So I think of an up parabola and a down parabola. Even if I'm dealing with a quartic, I still think of a parabola because it has an even exponent. What do you know about the end behavior for an up parabola? And a down parabola? Down, down. I'm thinking we should stop there because we're going to get into something called multiplicity. Do that period 3.